Students, see you again. In this video, I record a video for you. I need you step up to another level, another module in the CATIA program for simulating the mechanism movement. Let me show you. I bring you to another module. Going to digital mock-up module, right? Go to start menu and scroll down and digital mock-up and focus on DMU kinematics. Uh, right now, the toolbar DMU kinematics it show you on screen and different from other. This one, uh, the tool for assign the joist, assign the mechanism, assign how you need to move the mechanism step by step, right? And pace to pace. And first, previous video, you have known about how to assign the constant for the pair of mechanism, pair to pair, right? Until it's cover over all of the over part, right? And then you got about the constant, right? On state. And right now, I need you deactivate it all, deactivate it all. And before that, you need to change. Oh, sorry. I need to create the shortcut menu from assembly. Uh, okay, kinematic. Didn't you kinematic? You forgot on this. And pass part design, part design. Part design. Okay, enough for now. And I click on the shortcut. I show you. Show you on the shortcut. They call it the workbench. Welcome to CATIA 5 V5 menu, right? This is the shortcut menu, and you you have done about the assign left area to left area, right area. That is the shortcut you often use at all, right? At all in your work, right? You select from left to right, right? And the right zone of the menu, right? Some menu is show on your screen like this. Right. Okay, right now I bring you to assembly design. Assembly design, right? And right now I told you before, you need to deactivate it all because when you use the workbench DMU kinematic, right? And that tool need you to assign about the joy in the relative consent. Relative one relevant with another, another, right? Okay, that you need to assign the joy and change calling this condition become two joints, right? The joint, the joint, and previous video I call that the consent because the consent and the joints, right, relate with other, relate with okay, right, similarity, right, okay, right, the same. God under the joint, okay, under the joint contain the consent inside. I'll show you right. I bring you to and guide you. You should do this. You should do it because I need you avoid the problem in the future. If you let everything activate, right? Everything activate, then maybe you will fall. You will face the problem during the step, right? In the step animation and set up the animation mechanism, animation of the mechanism. Maybe you will find you will face about the problem that means I protect you. I protect you. That means why I I guide I guide you. Okay, hit right button and deactivate, right? Like this, right? Okay, switch back to the DMU kinematic right now. Right now, you stay inside this module, uh, digital mock-up, and DMU kinematic, right? First, I will show you in the first pair. I need to set up relative relative movement between this wedge and the bed part. That's it, the first pair. Okay, I'm going to set up about and select on which one is better, and uh, I should select for defining about this relation, the relative movement of this wedge and bed, right? You see about this, and two part should it move relative each other? Okay, I think should be moving each other, go along with the linear, right? Okay, the linear what is go around each other, go linear movement, right? Okay, linear movement. You should this select the two bar. DMU kinetic, and this one, yeah, this one is the sort of the joy type. It's a joy type needed on your application. Okay, your application okay should be matching about which one is better, right? You select on that, and okay, and right now I need to move this other relatively with prismatic joy. Okay, prismatic joy. I it's open the to it's command block like this. And, okay, the first block need you assign about mechanism name, right? And this one and this is a parameter, and this command used for assign the tessellation and prismatic joint. Okay, this is a parameter in one line for part 1, line for part 2, and pane part 1 and pane part 2, right? And we will set up this pair to be diving or not, to be diving joy or not, right? Okay, if you need to this joy to be diving, right? Okay, you click on here, okay, and I start up at it. Okay, I assign mechanism dot one is the default name, automatic generate this name for me. And I click on OK. And line is co-align each other. And line for part one, line for part two is co-align each other. It must be going align each other, right? Okay, I see. I will give the parameter for this block. Okay, pane and this one is shifted. It's shifted to 1 millimeter, and part number two is part number one part, and part number two wedge, right? And this pair I will assign the relation by line and pin, right? And this is part number one already have the line because the line is the edge of blue part, right? Blue part. And number two, this one. And number two, they will have the pen shifted to one core line of the flat pen of a blue part. And right now in nothing. And the part rest in nothing about the pen core line with the blue wall, right? The blue is a side wall of the blue part. I never have, and the line it never have as well. That's it. the parameter not enough to filling in here, right? Mean I leave it first. I leave it first and go into this wedge, right? This wedge. Don't click inside. Switch to the path design. Okay. I hide of this first. Base path. Hide. Okay, I created the pane, right? Using about element, basic element command, right? Okay, and you find out about that too. That's it one. Pane. This one is pane. Page shift. You will see the horizontal toolbar, right? The horizontal toolbar and reference element, right? Okay, this one is reference element. Click pane and here offset, right? 1 millimeter, right? 1 millimeter. And click switch to this 1 millimeter. Okay, accept 1 millimeter. Here is 1 millimeter from this wall, right? This wall is right the shoulder of this. And line, another line is the line. I need to use the line, right? The point to point, right? And another way, use the point direction. Okay, I assign the point first. Assign the point first. Okay, I will assign the point because the line needs the point and direction is point. Right now I never have the point, right? The point in my screen, right? You create the point direct in this point bank box over here. You can do this instantly, right? But for me, I need to create separately, right? Separately, okay. I will create it. This point, right? Point. Okay, I use this point. Okay, default origin. I select on here default origin, right? And you go to y, right? You see the axis. Y is equal a line of horizontal, right? And C is a point to me, right? X is up there, and that's up, right? Okay, point is y in -1. Apply right here. No, miss. Okay, the direction show up. Oh, X. Oh, I missed direction. X, and this one is right. X. Okay. X -1. Yes, -1. -1. Okay, it's correct. Okay. I go in the line and click the point direction. And this one is point, right? And direction is along is this. Okay. So okay, again I click on here. This is the direction, right? I switch to opposite direction. Set up. Okay, length. Okay, the length. Edge of right. Okay, that's it. I got it. I got the line and the point, right? Right, and the point and the pin. The pin and line, and this is the parameter I need to use for create prismatic joint. Okay, turn back and double click on the product and these show up bed part here, right? Okay, I create a prismatic joint again, new mechanism, and this one prismatic joint number 1 and line the first part, right? Let me hide this part first. Select on here. Okay, the edge of the blue part, and this line number 2 is a line, right? Line of the part 2 here, and the first part. Okay, and the plane of the part, this one here. Okay, I click OK. I got it joint. You see application and mechanism. This joint, right? Pigmentic joint under the pigmentic joint. Inside of the pigmentic joint is contained and the coincident, right? Coincident. This one is a new relates on the pigmentic joint. Because it create the joint and automatically and inside contain about the consent, right? That means if you already have inside of the consent, maybe it's conflict each other. That means why did I tell you about, or you should deactivate the previous video. I will show you the consent, because this one is here the consent, and you can export, right? Export in the spit it out at all, right? And turn back easier, right? You click on the update and turn back to the product configuration, right? And right now I'm being you to new the topic, right? The simulation using about the joint, right? Based on the mechanism, right? On the mechanism part to part, and you can analyze catching each other or not, analyze the movement, velocity, something. You can do that. That is the DMU kinematic, right? Okay, right now you got the one joint already, right? And if I try to use the simulation, right, it is on the relative movement constant, right, this and it's calling the joy of this pair, right? Okay, right now the OF is the one, it can right now you cannot simulation, right? Because this one the degree of freedom is 1, is not 0. If you turn to the 0, okay, you can simulation and right and then the simulation, and that's way you need to set up about diving joy as well, and there is the diving joy. That's the program. It allows you use the simulation tools and movement and emulate simulation, right, and animate about the mechanism needed on the joy, right? Okay, right now it never have about diving. Uh, so I will click on there, right? Rank diving. Okay, and fixed part, right? And the relative movement. Now what have about fixed part? Because when you another move relative, right? In the compare with the fixed part, okay, and you see about okay how far is it, and form about the fixed part, and another part move far away, right? You can know about how far is it in the two part of the two moving on, right? Okay, and right now not yet set up about fixed part. That I will use this one fix the part, this part fixed to be in fixed, and right now mechanism can be simulated, right? And this the program. Okay, right now the condition is completed around you simulate your mechanism right now, right? I click OK, and you're going to set up about simulation, right? Okay, the simulation. Okay, uh, you will take input inside of the control box, right? Okay, I will show you about uh, another part, right? Before another part, I hide that here. I move here, right here. I move, right? Move move is the relate on about joint, and inside the joint, there are the two constraints, right? Okay, I move that. Okay, if I move, right? Okay, click here, insert, right? Insert is right the record the position to this command, right? And okay, going to here again, insert again. If you really far and another step far from its current point, okay, far like this, right? I need to make the simulation to move farther, move faster, right? Okay, I insert here, right? Okay, turn back very quick, like this. It very far is the long distance, right? Okay, I insert again. Okay, it's a 4 step. I turn back, right? This one in the every each step, okay, very small is the make your simulation is go slowly, right? Go slowly, and uh, you can see it, right? You can see it. Otherwise, very far you cannot see, and the step to step, right? Do amount of movement. Okay, I will show you move here. Far is very farther. It's far, right? It's farther. And the step last one step. Okay, fastest, fastest, right? That the limit on you move and insert. If you move, it's a wrong distance. Okay, then you make your simulation. It's farther that step, right? Farther that step. If you need to move slowly. Okay, you're going to insert step by step, right? Short length and use the short distance and make your simulation very slow, right? Again, if you move uh, back and forth, right? Okay, you click on here, back and forth like this, right? Back and forth, what do you have? See movement. Uh, okay, and this one is one direction. Okay. Right now I don't need keep it because it's not finished, right? I just done just only one pair, uh, right? Okay, I just cancel first, refer cancel first, add more part. Another way you can show up and the part hidden, right? Okay, you click on here, and this you found it in another window. This the window for hidden part, right? This one hidden part. Okay, click here, show, right? It turn back to be back again. Okay, right now there was one joint, right? There was one joint. You need to add more joint for this one. For this one. Another joy. Joy is the okay, the pigmentic joy and pigmentic joy. Same time, same way, because this one shifted 2 millimeter, 1 millimeter from the sidewall of the part brown color, right? Okay, you're going to set up about lifting part, right? Oh, center graph is bring you to that part, is on. You select that and click right button on there, right? And it bring you to about this part. Uh, belong to is blue. Sorry, belong to is green, right? It's a bright green color. And okay, you go here, this part, right? This part. Okay, I double click here, part design, and switch to the part design, the part design module, right? And uh, this one is the base part, right? And wedge part. Okay, I hide wedge part. Okay, I just create the line 1 millimeter pin. Okay, 1 millimeter and line. I need to create the point first. Okay, point right. Use the type method, the coordinates. Right. Okay, this is the point here. Shift that. Shift that. And show me. Okay, which and this part and this thing. Okay. You didn't know the axis. Maybe you created part the axis system, right? Or tile. Okay, you try 1 to 1, right? And otherwise you created the axis system to here. I will show you on part uh, something like this. Okay, I'll show you part here. Lifting have the axis system X, right? Okay, click on here. It's X, right? The direction X. Okay, you the point coordinate reference point here. X axis -1 here, right? Click OK. Okay, the line, point direction, and point here, and direction. Direction is the direction here, right? Turn switch back to opposite direction, right? Okay, have done that. Come back to the product again. Come back again. Okay, now switch part. Okay, not yet. Switch back. Switch back. Okay, create the another joint is prismatic joint. Prismatic joint is the mechanism one. Okay, correct. And line is the one, right? And it's uh, pin, there. Okay, line is switch. It's come here. Line, right? It's a line. Okay, switch back. Okay, line and pin this one, right? And this pin, we switch to another pin. This pin should be okay. Selecting about this the sidewall of the brow part. Okay, click OK, accept that. Going back. Okay, already done about the second joint. Okay, the second joint. Right now, the degree of freedom one, right, is not completed. Should be 0. Delete the program allow you simulate your mechanism, and it equal one, you cannot simulate your mechanism anymore because it's one left. It's one left. You you must assign about one left degree of freedom. Right? Right now, it's not completed. Assign all of the pair. Right? In this case, it's a pair number one, pair number two, and not enough because it's the less of one degree of freedom, not completed assign. Right? Okay, you need to assign that because it's one diamond. Diamond number one, I set up a diamond right the linear dive, right? And if you set up here, we come to diamond again. That means you're going to have the motor and linear diamond, right? Right, the activator. You drive it's one prismatic joint. You drive by the external force, right? And if you drive it again, because you need to complete it, degree freedom zero, right? Because the left is one degree of freedom, not completed that side, right? Okay, you're going to set up here. Okay, you can, but you need to use two activator, right? And you're going to cause your system more, right? Okay, that did not allow you some do like that. Except the another mechanism like the robot arm. Robot arm is the okay elbow is one activator, and the shoulder one activator, elbow one activator, and wrist of the robot arm one another one activator. Okay, the makes sense. And this one is the right the cause mechanism. Okay, normally use just only one divet, right? And right now, if I I stumble to do this, okay, I use it. It allow you already. Okay, there are right now there are two diver, right? Okay, how to set up? Okay, you're going to here set up, right? The mechanism and this one. Okay, it show you two command because it's a two diver, right? Two diver. Okay, it's a okay, it's a diver. There are two diver. Okay, you set up here. This set up here. Okay, show you here. Turn back the normal. Sorry, turn back the normal screen. Oh, sorry. Mm, okay, come back, but because it, okay, I cancel it first, right? So where is that part? Okay, right here, here, right here, and show you. Uh, okay, because I didn't mean in the high of this. Okay, actually you can. Oh, okay, high of this part enough, right? Okay, okay, so ready, uh, ready. Turn back. I come back to the mechanism, right? Okay, so how to simulate your mechanism and the joint you already done before two pairs. Okay, this mechanism. Okay, it's the independent drive, right? And it's the brown part, the bright linear diver, right? Right. And this one, the clean color, and another command drive, right? Okay, if do this here, 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 something, I add. Okay, add something, add. Okay, right now it right independent each other, and then you assign about it, and the panel one panel two never have engaged each other, and the right independent assign the driver is the drive the part, right, movement. here, right here. These the two that you assign how far, and the command number one control the brown part move, right? Move to somewhere, and this one another command two independent with the command one, and you can assign about how far is the part number two, right? Move far away from part number one, something like that, right? Okay, this one is the command, the driver is more than one, right? Actually, this one is the cost mechanism. It should be using the one command and enough, and that enough already, right? It's not the same of the robot arm, right? The open mechanism, right? That that allow you use is the command independent each other. Okay, this one I next come back, right? And you cancel, I not keep that, I not keep that. Okay, I just uh I just set up it's just only one drive. Only one drive is still keep uh, keep the message show you about no longer simulated. Right? That means you couldn't simulate anymore right now. Right? Okay, is one left degree of freedom not completed. You need to find out about another joint. Another joint it means it's right the constraint. Yeah, you need to add up more constraint, right? It cause two degree of freedom become to zero, right? You need to do that, right? Okay, I assign it because you notice it before simulation for you already. Uh, you notice about it that before that simulation, the movement before, and this far away from the center, really the center there. Uh, there was about the pros, there was the pole, right? I told you that before. There was a pole in the center of the part, right? Because this part and the poles go through about the center hole, right? Go through the center hole, and right now I never created the part, right? The 3D show on my work, right? I just know about okay in the center there was the 3D part, right? That's it. If have the pros at the center and the green color, it cannot pass across of the center, right? It, it could not, right? It could not because have the post stay the center. It's not around the green part, or the brown part go across of the center, right? That means allow just only one direction around the green color. The green color is move up, move down. That's it. The around green color is move up and move down. That's it enough, right? Because it's constant, it's a block the path green, and you cannot come across of that, right? It's come across of the center. Yes. Okay, I need to assign the consent more. Need to tell about the price not around go across of the center anymore. Yeah. Okay, just about here. Cylindrical joint. Cylindrical joint. Okay, and mechanical joint. Right, in the line, and one line near the center of the cylinder. Part number one. The center of the part number two, center of the cylindrical of part number two. That's it. Okay, part number one, the center is okay, go here. Center of the blue part, center of the green part, right? Here. Okay, good job. That's it. That allow you already. Because the one consent left, and right now I feel the consent more using about the cylindrical joint. And right now it's completed, done very well, right? Allow you simulate it, right? Okay, right now the command just only one left, right? The only one left. The command just only one. Only one is control on off the joint. I click on here. Right now, it just only one command, right? And control the two pair, right? Okay, I just did here, here, insert, here, insert, right? Here, insert. Okay, here. Okay, the green color is move up, move down. That's it. Right, that's it. Yeah, move up, move down, move up, down. That's it. It's correct. Move up, move down, move up, move down. That's it. Okay, it's correct, right? And green color never far away from the lamp, right? Move on the lamp. It can. Right now it's could not, and now it's could not. Require inside the consent. Go up, go down. That's it. Okay, finish. Click cancel. Add more. Okay, the brown done, clean done, and right now there are one and two left another repeated. Okay, and you so assign the constant more here. Okay, hide. Okay, you're going to hide it. Put the here, hide here. And the joy, right? The joy of this should be sphere, right? Spherical joint. Okay, try it out. Try it out. Click here. Okay, what kind of thing this command need to use for creating the spherical joint? It's a point and point, point and point, right? Point and point. Okay, cancel. You can use a point and point. And actually, and actually this part just only oh, leave, right? This one, the high of this part. If you high on here, okay, that's it. Easy. You can just use it. High. And you come back easier. Okay. Actually, and this one, green color and red color should be engage each other, and then green it go up and red it go up too, right? This is really simple because the spherical joint maybe in the part the red color and the green color and rotate each other is rotate and is rotate around of the center, right? And this case you it's not necessary to set up about spherical joint, but because I need to use the joint engage the red color with about the green color, that's enough for me, right? Okay, that joint is the rigid joint, okay? Engage each other between about here, red color and green color, okay, engage each other. Okay, accept it. Still be simulated around you simulated. Okay, good. Try again. Try again. Okay, move. Right? Okay, the red color go up, go down relates on the green color part, right? Because this one using about the rigid joint, right? Okay, done. And here, this one is screw, right? It's screw joint, screw joint. Okay, I will set up more screw joint here. Screw joint, this one screw joint. What kind of input? This work required, right? That's one screw joint line and pitch. Like pitch. Okay, pitch mean pitch. Pitch, yeah. Descent. Pitch descent. The peak of the thread. One thread, the peak of the thread. Uh, how far peaks of thread to another peak of thread. Okay, this one I call that peak. Pitch descent, right? And 1 millimeter is the peak to peak, right, of the thread. Peak to peak of the thread and 1 millimeter, right? Okay, I set it up. Okay, take on here. Okay, sure. Okay, degree of freedom 1, right? It's 1, it's over. It's over. It should be 0, right? Actually, it worked very well. And right now we come to 1. It's going to not work. Going to not work, right? Because it's 1. Actually, how can I solve? I will solve the problem. So you assign more diamond, it's not good the way from solution. The way for the solution is not good, right? And if you create more diamond, and I suggest you could do that. And this one, another one, okay, add up the more consent. Add up more consent, okay, is a good way to do and solve the problem the right way, right? This is the right way because you need to control all of the part using about the one diver, right? Right? Because it's a diving part, right? Diving part is right now. Diving part is the blue, right? Because I said about the blue. Actually, the diamond part should be here. Screw, right? You rotate screw, you drive the screw clockwise. That screw, the direction is clockwise, right? And the part, brown part, it should be moving forwardly, forward. And anti-clockwise, it should come backward, right? Okay, this is the guideline of this assembly part, assembly product. Okay, and this you need to control and block the cyan color. It couldn't move through about the blue color, and just this part should be moving around of the center of the part, moving about is around of the same position. It's not forward, it's not backward. It's a move around of the center itself, right? And because this part, it should be blocked. It should be blocked of this part. Couldn't move through the blue part, right? It should move through. right? Because the wall or the blue part is blocked. The cyan color part cannot pass through. Okay, this one it should be another constraint. Okay, another constraint is pain joy, right? Pain joy. Okay, because this is the joy, right? And this flat surface touch the cyan color flat surface, right? Is other relative movement, right? Right. The pain to pain, right? Move along of the pain area, something like that. Okay, pain number one, this pain number one. Pain number two, this pain number two. Okay, okay, that's it. Can be simulated. Okay, it's done. Done. Like this. Yeah. Okay. I move right here. Okay, cancel. I should be using about this school diving part, right? Okay, school diving part. Okay, right now you do set up, and here I move it. It never use it. Become to diving part anymore, right? I will use it to be diving, right? Here, diving, diving part. Uh, okay, accept it. Accept that. Hey, move right here. Okay, here. You see here. See here. Like this. Right, but and the length is not enough, right? It's one round. It's a one round. One round is 1 millimeter because one round the move relates on the pitch distance. With distance millimeter is one round move 1 millimeter far away. That's it. That means you must calculate. Okay? How much should I set up about the number of the round movement? Okay, how many round? It's move this part to this because it's a brown part and it's, it could move pass through about the center, right? It cannot. Okay, you need to calculate it first. Okay, the SI about uh, the how many is round, right? Your, how many round uh, how many round rotate about the screw and control the wedge part to the center, like you calculate it first. Okay, right now you cancel first. Let me hide go hiding this. Go hide this. Go hide this. Right? Okay. You need to calculate how far the center is the curve to the center is the curve. How far? Because I need to protect this part. It to go past across of this across of this hole, right? Okay. You find out about the two measure and create it. You set up about the first point here and another point here. How far? 24, right? 24. 24 millimeter. Okay, cancel. 24 millimeter. 24 millimeter. I find out about the calculator. It's a calculator. Calculator. Here. Click on here. Uh, okay. 24. How many round? Okay, 8,640. Okay, I will set up the length. Click on the diver. The diving part is screw, right? I will set up. Okay, set up this position, right? The 0 and this one degree right here. You try. You try the error. Let's see. Try it again. Try again. Okay, this one. I need to type in manual. It's copy paste. Maybe it's copy. It's over the number, right? Right, a fear, an alien letter included, right? Included maybe, right? Okay, I just use this directly. Click OK. Okay, check again. It come here or not? Okay, correct. Uh, Let me use this simulation. Oh, okay, it's going to here and come back. Come back, right? Okay, mechanism. Right now, set up 0 to here. Oh, sorry. Come back again. Groove, right? I see here. Zoom out, right? Okay, just lever the direction. Click OK. Okay, you come back again. I did. I did. Okay, adjust it. I move thoroughly. Insert. Move a little bit. Insert. Move. Insert. Move. Right. Stop here. And not go across. It cannot go across of the whole. Insert. Right. Okay. Right. Come back here. Here is slowly move. Right. Come back. Quick. Faster. Okay. If you move farther. Okay. Good. Another case problem. Maybe you didn't look over about this part. You should look over this part, and this part, the brown part is the penetrate material to a screw, right? Penetrate. Okay, I just move it. move it, this part. Okay, I'm going to move using about here, right? Go about here. Okay, come back, come here, touch, and move, right? Move like this. Move that. Okay, you come back, take compass, go home, here. Yes. This touch, right? Okay, I will use the hybrid with hybrid function with assembly. Okay, I just told you before, use this to snap, right? Okay, this pass, so snap here, like this. Okay, right now just touch it, not penetrates into about the cyan color part right here. Going to DMU kinematic, back to DMU kinematic, right? There. Okay, mechanism one. Okay, current for rigid joint, right? Click OK here, like this. You start again. How many round? And this current position going to stop the edges, core line edges about the curve, the brown and blue, right? How many round, right? You just calculate again, right? Okay, I just high, right? Okay, going to measure here and here, 18, right? Okay, 18, you come back, 18, the calculator, right? 18, 6480, 6480, 6480, 64, okay, here, 6480. Okay, that's it. Come back, come back. With simulation. Okay. I never have the simulation. Here, insert. Here, insert, right? Here, insert, insert. Done. Finish. Right? It's line edge. The curving edge, the curvy edge, and the brown and the blue line each other. Here, turn back, right? Turn again. Okay. Finish. Okay, I keep it. Save. Okay, save. Save to the history tree. History tree appear on the new folder. Under the folder have the simulation about double click come back, right? And okay, show you about the simulation again, right? Here, okay, that's it. And right now I bring you to the real time. uh, you can look over the distance at the start and height, the height. When you control height and the page is go up to the height distance, the page go up to okay, you can calculate, look up about here. You can use it the normal way. You keep the distance first, maybe, right? Keep the distance here, compare with here something, right? And it's go up, you compare again. Okay, I just did. Maybe I just two option to set up it first. Display, parameter, measure tool, right? Automatic update part, right here. Automatic update. Okay, click OK. If you click on here, you keep update the measure. Okay, I just measure 1 to 2. I got it distance, right? Keep OK. Distance, where is it? Again, where is it? Keep measure, right? Here and here. Keep it. Oh, okay. You see here, I moved it, generated. Okay, and come back to the 4. This one, the tree history is a measure is pop up in here. It's pop up in here, right? Okay, I need to delete it. Delete it again. I will try again. If you need to measure, right? Measure here. Use measure here, and this one. I use it the infinite, right? In this infinite. Okay, I just measure here, and this here, this one here. It's measure. It's the parallel each other, angle 0. Okay, it's very clear. This right, the infinite pane, pane to pane. Okay, 33.42. Here, and click OK. Click OK. Right, right here. You see the update, right? Update. And right now, this is the start point, right? The start point. Start point. Start point, right? And double click here. You're going to maximum, into maximum here, and 36, right? It's 36. and the 36 is the maximum, it's the highest, uh, highest, highest, highest of lifting. Is the lifting part, less something on the top, right? Less to 36 compare. This is a reference, is a cloud, right? It's cloud. Okay. And you see here is update. Right? Go up, go up, go up, go up. Here. Okay, this is the start point, right? If you need to see about, okay, far, the highest, right? Height. Going to need to measure maximum, right? Measure maximum. Here is the maximum, is the start point. You subtract each other. You get how far is it when you count from start to the highest lifting, right? Lifting is less up, right? How far is it? You can know that. You can know that. Okay, this one. Okay, this you see about and find out the updates. This then another option. Will show you here cache, right? Cache. You set up cache, contact and cache, right? Here. Okay. Double click. Double click this simulation. Simulation right here. This one. Select between all of that mechanism. Right? Apply right here. Show you right this. Show you right this. It analyze for you. The analyze wedge bed, right? It's contact. The contact. It's contact. This one is cache screw, right? The screw touch, touch the slide, the lifting part, right? Penetrates into the green color part 0.3. Right? Okay, we show you like that. It's cache, and this one contact is 0. The 0 is touch each other is 0, and crash. You need to solve the problem. How to solve that? You solve that. Maybe you just adjust this part, adjust this part, right? Adjust this part and okay, this is the limited of the school, huh? Not far away from limited distance. Okay, you calculate it. You cannot go into this position because this position is crash, and the material of the cyan color part penetrate with the into about the green color part, right? Another way you must set up about here. This is the shoulder both, right? It's more here, more, because you need to lift this one is higher than this, right? So the problem, right? Okay, this and another tool, right? You see here, and this one analyze, right? Analyze touch and contact on off the part, right? You click on there here and click on here. Click on here and you analyze contact and crash, right? And this one is the most used of option. And between on off the component, analyze each other and go another part and check it again, on off that, right? Between all part, that meaning. And click OK, you found about you will find about the cache position, where is the cache position happen. Okay, you can solve that problem, come back to the part design again, and solve and design, redesign again, something like that. And another way you analyze, right? And right now I use it one, cache detection is off, right? If cache detection on, right, when this system running, right, and stop simulation, if the program found uh, found is a cache happen, where is the cache happen, it should show you, and then in that time, right, immediately. Okay, show you here and click right now here, and the red color will show up, right? Show up, and due to the a lot of the resource in your computer, right? Yeah, yeah, okay, it's cache, right? Okay, I need, okay, cache. Okay, pause, right? Pause. And this one stop, right? And this one is the detail, is red color, just detail, it's not stop. And this one is stop, stop. Okay, I play again, and right now it's come back. Okay, again it stop here. Oh, okay, come back again, stop. Okay, play. Okay, stop. Stop already. Right, stop already. Right. Okay, you analyze. Okay, it's cache. Here it's cache already. 0.384, right? Okay, show you here, yeah, over here, right? The position, it's cache and stop, right? You can inspect, right? Look over part to part, where is the cache happen. You stop, you can use it stop, right? And analyze, and it come back to the design again, and reduce and add up the space for this part, right? Okay. Okay, if I leave it show just the red color. Okay, show you in red color, right? The red color is touch, and this one is cache. Okay, stop, stop. Okay, show you red color, stop, and this don't care about cache, right? Three option, and this one you analyze and set up uh, the type of inspection. You can analyze uh, some function, inside of this tool, right? Cache contact, right? Turnaround something. Okay, finish. Come back. Come back. And click OK. Uh, if you done of that, you choose you choose it high of this. Okay, double click in here and double click here and tool and high of pen, right? And tool high of the line something, right? Okay, high of this. Okay, and this uh, high the constant, right? High of the constant. This high and this one. Oh, okay, it's high axis system right here, and double click in the green part into high to high line and to high pin like this, right? And this point, right? Point high this direct this. Okay, this one like this. Oh, sorry. Okay, come back. Double click here, going to high the point, right? That's it. And you can okay, come back to the product, right? This two, another two is okay, sorry, this one, this one, this one you can use it comprise simulation. You can record the video. If you clean up your screen, your part already, you hide line, you hide pen, you hide the exit system, you hide line at all. Okay, you clean your part and assign the color. Maybe you assign the apply material something, right? You can record the video, generate this codec, right? Set up right here. It's for using a default and file name, right? And you set up the file name for this one video assembly, right? It's AVI, and this one lip sync leveling video, save like this and simulation. You use you have just only one simulation. Okay, use it as step 0.4. Okay, click OK. And it's running everything. Simulation one, you set up all the parameter already before that, right? You got it. Okay, you got the video, right? Okay, we back to folder, right? For the this one. See, okay, you see here, this one, right? Okay, I forgot. Yeah, I got hide of this tree diagram, right? Okay, you go into hide this. Okay, you forgot on the top menu, and this one F3. Okay, go hide F3 here, F3 and show you if you need to record about your part only, right? You can press F for 3, right? And hide the 3 diagram and record the video using about here. I will set up again, right? Set up and file name. Okay, here I need to the rerunning, rerunning again. 0 4. Okay. You can rotate, right, between during its running simulation. Okay, done. I got it. I will 4 3. Come back. Another way you can use the capture program is outside, right? Program outside. You can use that one. Capture the video. I think it's better than using about it. The little function inside the CATIA program. Use the comprise simulation, right? You can use that. Another tool in the outside is better. I think that. Okay, going to the assembly. this one, like this. Okay. And another tool, right? Okay, you have done it. And another tool is create a video under the tree diagram, right? Okay, you just here generate the repair, generate the repair first. Okay, repair, create it. Let me show you on here the tree diagram, right? Okay, you're going to here, just pay the repair function on the tree diagram, right? Okay, right, come back here, quicker and faster, right? Okay, like this, okay, this is something like this. This video keep inside of the tree diagram history. Okay, you can use the tool like this. This one is a simulation. Okay, all of that. Don't forget save your DMU kinematic, right? The projects, right? Okay, save management. You're going to the path list inside of the trade management, right? You see here you modify, look up about the state. The state is you have a bit uh, modifying, right? Have a bit modifying in your part, in your product, right? In your parcel line, in your parcel group, in your part range, right? Something. Okay, I forgot on the product first. Save as. Okay, I need to define the new folder. DMU kinematic, right? The DMU. Right? Okay, and I click inside. And I saved it. Leveling. Maybe I set up the MU because I need to uh, set up in different from the just assembly, right? Assembly topic, right? The topic of the MU. I need to set up a bit, right? Fill behind of the leveling, right? It's really create different from the previous, right? Okay, this one, okay, save. Think this. I save its product because I need to set up application. I need to download and set and write the copy everything into the new folder, right? Okay, the new folder. This save a new folder, save. Uh, okay, the open and everything is modified. Step, right? Because right now you're going to see here the different location from different from the previous, right? Previous is SMB, right? Okay, right now at DMU, and then allow you save, right? In save here, click OK. Everything is saved to the DMU folder, right? Okay, and now it's completed. Okay, so now you have known about the DMU kinematic, how to set up, and you set up and create a joint, you set up the pair of parts, a pair of parts, and how the relative movement each other, right? You set up the joint, and the joint created the constant as well, right? That means you protect each other and catch each other from the previous consent. I suggest you just deactivate the old the consent from the assembly first, right? Okay, and right now you have known uh, animation and kinematic and assembly and consent and export view, right? And including about the previous video I reported in the YouTube already. Okay, right now I finish here. See you again next video.